All right, 2.3. 2.3 is a big one. It really brings back our Algebra 1 skills about linear functions, which again are straight lines. And it brings back how to graph using slope-intercept form, how to graph using your x and y intercepts, how to take a point, how to make from a point into a line, all these different things. So we'll do a couple quick examples to sort of support you guys from what you saw in our notes today. So first thing that they bring up is being able to tell if something is a function. So in order to be able to tell if something's a function, the first thing you like to check is to look at your x value. So I'm going to look here at all my x's, and I'm going to think, how much am I adding? How much am I adding? How much am I adding? So to go from 4 to 11, I'd add 7. To go from 11 to 18, I'd add 7. To go from 18 to 25, I'd add 7. So it's consistent. So we're on the right track for it to be a linear function. So then the next part is to double check and make sure our y's are changing at a constant rate. So to go from -6 to -15, we'd minus 9. To go from -15 to -24, we'd also subtract 9. And then to go from -24 to -33, we would also subtract 9. Okay, so on here, yes, it's a linear function. Okay, and actually we can figure out what our slope is, because remember your slope is just the change in y over top of the change in x. So if I wanted to know what my slope is, my y is changing by -9 and my x's are changing by 7. Okay, so that would be my slope. But again, the main thing we're focusing on right now is being able to tell, is it a linear function? Yes, it is, and there's what it is. Okay, on number 2, let's try this guy. So looking at my x values, each time it looks like I'm going down by 2. All right, if I check out my y's, I am minusing 2. Oh, I'm minusing 4, and I'm minusing 8. So my x's are consistently changing at -2, but my y's, which again is the same as saying f of x, are not. So this guy is a no, and that's all you got to say. All right, second thing we talked about in your notes today was finding your intercepts. So when we are finding our intercepts, please remember that if you're finding your x-intercept, okay, that means you don't know what your x value is, but your y value is 0. And when you're finding your y-intercept, you know that x is 0 because you are finding y. So your unknown is y, your unknown is x. So using that big idea, let's go ahead and plug in some values. So if I am finding my x-intercept, I am going to have 6x minus 2. Now again, when I find my x-intercept, I know that y is 0, so equals 24. So super nice. This guy's gone. You're really solving 6x equals 24. So it looks like x equals 4. All right. Then when I go to find my y-intercept, this time I'm putting a 0 in for my x, and I'm leaving y alone to solve. Okay. So 6 times 0, gone. Please don't forget about that minus sign or that negative sign in front of the 2y. So divide both sides by -2. It looks like our y is -12. Okay. When you write your answers, please make sure they are written as coordinate points. Super, super important. All right, and if they asked you to graph this, let's see, we would need 1, 2, 3, 4, but then we might need, and I'll just go these guys by 1, but my y's I have to get down to -12, so maybe I'll go like 2, 4, 6, 8, 10, 12. I'll put those on there. All right, so to plot those points, we would have x-intercept at 4, y-intercept at -12, and then linear function, so straight line, we're playing connect the dots. All right, how do we graph 3x plus y equals 5 if they don't ask us to do intercepts? Well, probably the best thing to think about is y equals mx plus b, so putting in our slope-intercept form, remembering that the m is our slope, the b is our y-intercept. So if I rearrange this, let's see, we'd have to minus 3x, so we get y equals -3x plus 5. So there's my equation. Go to graph this guy. I need 1, 2, 3, 4, 5 on my y. I'll put a couple going each of the other directions. All right, plotting my y-intercept first at 5. 1, 2, 3, 4, 5. So nice big dot there. My slope is -3, so that means I fall 3. 1, 2, 3, and I run 1. Fall 3. 1, 2, 3, run 1. Once you get a couple dots on there, probably 3 or 4 of them would be great. Play connect the dots as best as you can. There is your linear function graphed. All right, last problem is how to write an equation from a slope and from one point. Okay, so there are a couple different ways to do this, but if we relate it back to y equals mx plus b, we know what the slope is. They just gave us that, so I'm going to put that in there, negative 1/3. We also have a coordinate point, which is x and y. So I'm going to put the x in where I see x, and I'm going to put the y in where I see y. So what's unknown in this? Well, our y-intercept's unknown, so I'm going to solve this. So negative 1/3 times 6 gives me negative 2. And then in order to get that b by itself, just add the 2 over. Looks like I have a b value of negative 2. So now I know what my y-intercept is. I already knew what my slope was. So when I write my equation, y equals negative 1/3 x minus 2. There's my equation. Again, practicing our graphing. I just throw a couple each of the directions. All right, so if I go to graph this y-intercept down here this time at negative 2, my slope is negative 1/3, so I would go down 1 and then run 1, 2, 3. So there's my new dot. I could build another one if I wanted to off here to the right, or I could go backwards. I could go up 1 and back 3, and then I have a little more room. Play connect the dots, and there we go.